Okay, we're going to do some definite integrals. Definite integrals are when you've got limits, which you'll have seen. So let's first of all try x to the power 4. So add 1 to the power, divide by my new power. With definite integrals, you don't add on the constant of integration. Upper limit of 1, lower limit of -1. So let's make the substitution in. So the upper limit gets subbed in first for x. So it's 1 to the power 5 over 5, close the bracket, and then we subtract and open up and sub in the lower limit, which is -1. Okay, 1 to the power 5 is 1, so that's 1/5. Take away, okay, so -1 brought to the power 5. So if you've got a negative and bring it to an odd power, it remains negative. So that's -1 over 5. 1/5 minus -1/5 is 1/5 plus 1/5. Final answer is 2/5. Okay, example 2. We've got an upper limit of -1, a lower limit of -3, and we're integrating 9 minus x squared. Okay, so you integrate a constant and it becomes a constant x. 9 will become 9 minus 9x minus x cubed over 3 between -1 and -3. So again, let's sub in the upper limit first. So that'll be 9 lots of -1 minus -1 cubed over 3. Close the bracket, minus open up. Now sub in the lower limit. That'll be 9 lots of -3 minus -3 cubed over 3. So that'll be -9 minus 1 cubed is -1 times that by -1, that's +1 over 3. -9 times -3 is -27, and then -3 cubed is -27. -27 times by the -1 is +27. +27 1 divided by 3 will be +9. Okay, so -9 will be -27 thirds plus 1/3. -27 plus 9 is -18. So that's -26 thirds plus 18. Okay, so -26 thirds plus 54 thirds, and that is equal to 28 thirds. Okay, let's try another. We're going to integrate between 3 and 1, x squared plus 2x. So that'll be x cubed over 3 plus 2x squared over 2 between 3 and 1. Let's definitely simplify first before I make any substitutions, and that'll be x cubed over 3 plus x squared between 3 and 1. I can now substitute. So that will be 3 cubed over 3 plus 3 squared, close the bracket, minus open up, and sub in 1. 1 cubed over 3 plus 1 squared. Okay, so 3 cubed is 27, divide that by 3 is 9, plus 3 squared is 9, close the bracket, minus open up, and that will be 1/3 plus 1. 9 plus 9 is 18, minus 1/3 plus 3/3, so that's 18 minus 4/3, and that is then 54 thirds minus 4 thirds, which is 50 thirds. Okay, let's try an example 4 and introduce some fractions into play. I'm going to integrate x to the 2/3 between 8 and 1. So add 1 onto the power, divide by my new power. So 2/3 plus 1, well, remember that's 2/3 plus 3/3, and that's where the 5/3 is coming from. Between 8 and 1. I'm then going to bring the fraction up and flip it over, so that's going to be 3/5 x to the power 5 over 3 between 8 and 1. I'm then going to use my rule of indices, which is a to the power m over n is equal to the nth root of a brought to the power m. so that I can then make a substitution. So that's 3/5 of the cube root of x brought to the power 5, and that's now ready to make a substitution. Okay, so first of all, sub in the upper limit of 8, so 3/5 of the cube root of 8 brought to the power 5, close the bracket, minus open up. 3/5 of the cube root of 1 brought to the power 5. Okay, so the cube root of 8 is 2, so that's 3/5 of 2 brought to the power 5. Minus open up, and that will just be 3/5 of, well, the cube root of 1 is 1, 1 to the power 5 is 1, so it's just 3/5. 2 to the power 5, take your time with that, that's 32. So it's 3/5 of 32 minus 3/5. Okay, so that will give me 96 over 5 minus 3 over 5, which is 93 over 5. Okay, let's try an example 5. I'm going to integrate between 1 and 0, x to the half plus x to the 2/3. Okay, so add 1 on the power, divide by the new power. So 1/2 plus 1 is 1/2 plus 2/2, which is 3/2. Then divide by my new power, which is 3/2, plus x to the 5/3. Since 2/3 plus 1 is 2/3 plus 3/3, which is 5/3 divided by 5/3. And that's between 1 and 0. Okay, so that's now, bring the fraction up, flip it over, so that will be 2/3 of x to the power 3 over 2 plus 3/5 of x to the power 5 over 3 between 1 and 0. Okay, so let's reintroduce the root symbol. So 2/3 of the square root of x cubed plus 3/5 of the cube root of x brought to the power 5 between 1 and 0. Okay, I'm ready for subbing in. So 2/3 of the square root of 1 cubed plus 3/5 of the cube root of 1 brought to the power 5, minus open up, and 2/3 of the square root of 0 cubed plus 3/5 of the cube root of 0 brought to the power 5. Okay, so that's now 2/3 plus 3/5 minus, and this will all collapse down to 0. So let's get a common denominator here of 15, so top and bottom be 5, that will be 10/15 plus 9/15, which gives me a final answer of 19/15. Okay, let's try another, and we're going to integrate between 4 and 1, 3y to the 3 over 2 minus 5y to the minus 2. Okay, so 3 over 2 plus 1 is 3 over 2 plus 2 over 2, that's 5 over 2 divided by my new power 5 over 2 minus 5y to the minus 1 divided by minus 1, so that's because I'm adding 1 onto the power minus 2. That's between 4 and 1. Okay, so bring the fraction up, flip it over, that will be 2/5 of 3y to the power 5 over 2. These two negatives cancel out, and that will just leave me with plus 5y to the minus 1 over 1. Well, I don't need to write the over 1 there. Okay, so let's just tie this up a wee bit before we make any substitutions. So 3 times 2 is 6, that's 6/5 of the square root of y brought to the power 5. And bring that back down, and that's plus 5 over y, and that's just using the reciprocal rule of indices, a to the minus n equals 1 over a to the n. For dealing with that, I used that rule. Okay, between 4 and 1, I'm now in a position to make substitutions. So 6/5 of the square root of, first of all, sub in 4, brought to the power 5, plus 5 over 4 minus, open up, and now sub in 1, 6/5 of the square root of 1, brought to the power 5, plus 5 over 1. Okay, so the square root of 4 is 2, 2 to the power 5 is 32, so it's 32 times 6 over 5, so that will be 192 over 5, plus 5 over 4, minus, okay, so the square root of 1 is 1, 1 to the power 5 is still 1, times 6 over 5 is just 6/5, plus 5, so I'm going to write that as fifths, 25 over 5. Okay, so I'm going to get a common denominator here of 20. Okay, so top and bottom here before, 192 multiplied by 4 is going to give me 768 over 20. And top and bottom here be 5, so that's going to be 25 over 20 minus 6/5 plus 25/5 is 31/5. Okay, so 768 plus 25 is going to give me 793 over 20. I'll then multiply top and bottom here before, and that will be minus 124 over 20. And that will then give me 669 over 20. Okay, let's try an example 7. And let's integrate between 16 and 9 the square root of x. Okay, so part of preparing to integrate is to get rid of the root sign and put in a fractional power. So that's x to the 1/2 that I'm integrating. I'll then add 1 onto the power and divide by my new power. So that will be 3/2. So x to the 3/2 divided by 3/2 between 16 and 9. Bring the fraction up, flip it over, that's then 2/3 of x to the 3/2 between 16 and 9. And reintroduce the root, so that will be 2/3 of the square root of x all cubed between 16 and 9. That's now in a position for me to make a substitution. So let's do that. Okay, so that will be 2/3 of the square root of 16 cubed minus, open up a bracket, 2/3 of the square root of 9 cubed. Okay, so the square root of 4, 16 rather is 4, 4 brought to the power 3 is 64. 64 times 2 is 128, so that's 128/3. Minus square root of 9 is 3, 3 cubed is 27, times that by 2 is 54, and that's 54/3. So 128/3 take away 54/3, which will give me 74/3.